encoders and decoders. So first of all, what is meant by the sequence here? Sequence here means the input sequence. And if we are taking an example of NLP, then this input sequence will be in the form of a text. Similarly, the second sequence that we are talking about is the output sequence. Again, if we are taking NLP application, then this will be an output text. And then encoders and decoders, these are the two main components of the model. So from here we'll drive out the definition for this, that is sequence to sequence learning with encoders and decoders is a type of deep learning model, and that is used to solve the task where input and output are both sequences, and encoders and decoders are its two main components. So this is the definition for this model. And then is let us understand the topic with a case study where we are to convert a English sentence into French. So let us take an English sentence like I like programming, and correspondingly in French it is J'aime la programmation. So for this the solution is sequence to sequence learning with encoders and decoders. Then is in this we can use RNN, or alternatively we can also use LSTM. But RNN is less preferred and LSTM is more preferred, and the reason being that this RNN struggles with long-term dependencies. It is good for short-term dependencies, but it struggles with long-term dependencies. And LSTM, it captures both short as well as long-term dependencies. So that is why LSTM is more preferred in this sequence to sequence learning. Then is for this particular model, let us take 4 encoders that are linked to each other. Similarly, we'll have 4 decoders. Again, these decoders are also linked to each other. Let us initialize the model with the timestamps. Timestamp for different encoders are taken to be t, t plus 1, t plus 2 and t plus 3. Similarly, for decoders, we can take a different representation of the timestamp, that is u, u plus 1, u plus 2 and u plus 3. Then is you give the inputs to the encoders. The first input that is given is I. The second input that is given is like. The third input that is given is programming. And the fourth input is the end of stream. End of stream contains all the 3 words. I like programming, because the relationship is also getting maintained. Then the output from the last encoder is W. What is W? W is the context vector. What is this context vector? It is nothing but a multi-dimensional numerical vector that encodes the entire information. Now from this context vector, we'll give the input. We'll give the input to the decoder, and decoder will generate the first output, that is the first word, that is Jamie. Then is the second word is generated, that is la. Relationship is also getting maintained between these two words. Similarly, from here we'll get the third output, that is programmation. Similarly, we'll get the entire sequence, that is end of sequence, that is J'aime la programmation. So this is the final output that is obtained. Then is similarly we can convert different languages like English to Hindi can be converted, English to Sanskrit, English to Mandarin can be used, Mandarin to French, and different languages can be converted into many different languages. Let us find out that input and output sequence order may be different here. Why? Because the count may vary, the timestamp may also vary. You can find out here in Hindi it is written 11 words. अपने मन विचारों और वस्तुओं के प्रति आसक्ति छोड़ने की भावना. So if we count the number of words, then there are 11 words. Similarly, when we convert this Hindi into English, then it is the feeling of letting go of attachment towards one's mind, thoughts and possessions. So 11 words in Hindi are converted into 13 words in English. So the count is getting varied. Similarly, if the count is getting varied, the timestamp will also vary. That is why different representation was given to encoders and decoders. Then is the application. We had already seen this application of machine translation for conversion from English to French. The second application could be image captioning. Since we are talking about image, so in image we'll be using the model that is CNN, that is convolutional neural network. So from this CNN we'll extract features. What features? Features like size, color, texture, shape, edges, boundary, and other visual features. And encoder will generate context vector of these features, and finally the decoder will generate the caption, that is step by step and word by word. So this is what is image captioning. Similarly, another application could be speech recognition. Just like the previous step where we have taken CNN, now here it is speech, so we'll be taking RNN. And again, the features related to speech will be taken, like MFCC, spectrograms, chroma features, and pitch. These are the various features. These features are converted into context vector, and again, decoder generates the caption step by step and word by word. So your speech is converted into text. Contrary to this, we have speech synthesis, where we convert text to speech. Again, the encoder that is taken is RNN. So encoder generates the context vector of the text, and finally decoders generate the sound. Here the sound is the output. So it generates the sound step by step and word by word. So these are the various applications for your sequence to sequence learning with encoders and decoders. So if you got some knowledge from this video, then do like, comment, share and subscribe, and thanks for watching.